Okay, great, guys. Well, look, thanks for watching this. If you're watching this on recording, then thank you for watching this. I know this was scheduled a day late, so my apologies for that. But my name's Nikhil Sehgal. I am the founder of two companies that have been through the Microsoft for Startups program. One of them is a company called Vastmindz, which deploys software, AI software from remote health monitoring. And the other is a company called Neo, which uses GPT-4 under the hood to automate a lot of IT support functions for MSPs. And so I've been developing on Azure for many, many years, especially around leveraging the cognitive services suite to go from idea to the first dollar of revenue for that idea in the shortest time possible. And my whole goal with these talks is to help you go from idea to that first dollar of revenue if you are thinking of building this into a company in the shortest time possible. And there are many ways to, and I hope I can shortcut some development effort or time. That's my whole goal with these webinar series. So just some housekeeping. Anyone watching this probably already knows, but if you haven't already signed up to Azure OpenAI, you can do so via the Azure Cognitive Services Suite. You simply just have to go to this via the Azure portal to sign up for an instance. It's a very simple process. You will get immediate access to GPT 3.5 Turbo, but there is an additional application form for GPT-4. So you can just go ahead and fill that out, and you'll get access to all of the models. Okay, so let's just go on to the problem of what we're talking about today. The problem is everyone listening to this has probably used ChatGPT at some level, and the problem is that ChatGPT is a great question and answering tool, but it doesn't really know anything about a company's data or anything about the enterprise. So if you, let's say, have a scenario where you have an accountant in a company that, let's say, does the accounts every month for this company, and let's call this person Bob, and Bob has to go through the accounts every month, work out the numbers, work out profits, revenue, cost of goods sold, all of the stuff that an accountant would usually do, and trail through many, many tables within the company's databases to retrieve this information. If Bob tries to do the same thing with ChatGPT, obviously, it will return a message saying that it does not have access to any of his data, which is obvious. ChatGPT doesn't know anything about a company's internal data. It doesn't know anything outside of the knowledge that it's been pre-trained on, which is basically public sources of information up until September 2021. But this is pretty useful for someone like Bob who needs access to the company data. So the question is, how do we solve this? How do we actually hook up a GPT model to be able to fetch information from SQL tables or SQL databases? That's the key here, because then you have a situation where any user, not even an accountant, any executive can query and get an immediate answer or response about their company's data. So the solution is actually quite straightforward, and when I presented this a couple of weeks ago, I did get a lot of questions around this, which I'll touch on today. But it's very simple. You just need GPT to be able to execute SQL commands with a little bit of prompt engineering. It really comes down to those two things which make this whole situation possible. to avoid the fact that GPT doesn't know anything about the company's data. So it's really two key things: prompt engineering, and for you watching, you probably already know what that means, but I'll define it anyway. So prompt engineering is the art of modifying a prompt to get a desired output. That's really important when you are building an application that executes commands. Because when you're executing commands, you really want GPT to be spitting out variables or argument variables for you to actually pass into a function. GPT can no longer spit out in this case, it can no longer spit out, oh yes, you should do this, with a bunch of text around this. It needs to really spit out the exact things that need to be passed into an executor to be able to retrieve this data. And I'll again show you exactly how to do this. Okay, so this is actually a demo of a simple web application I built that hooks up in this UI. You can enter in any natural language message about what you want to retrieve. And what I did is I spun up a bunch of fake tables about finances. So we're still going to pretend here that we're Bob. And I spun up, a fake table about finances, and I put a bunch of fake data in there. And now we're going to try and query that data. So here you can see in this example, I am saying, show me all the rows where our expenses were greater than $1,000, for example. And you can see it's generated the SQL query for me. Again, it looks like a correct SQL query, and it's actually executed and shown me the results from the table that match my query. So again, flawless SQL query. I don't see anything wrong with that SQL query. And then it goes ahead and executes it. It gives me the query results. So I can try something else. Let's try this one. Show me all. Let's see what I pre-recorded here. Okay, so this is where we're trying to look for any points where we had losses. Again, the SQL query looks pretty correct to me. Profit is less than 0. And then it's executed it, and we can see from the table all of the rows where profit was negative or where we incurred a loss. Very easy now for an accountant to pick that out if they were using an application like this. The other query is, we could try some more complex ones. But let's see, in this query here, show me where we had revenue that exceed. Okay, this is a good one. Show me where we had revenue that exceeded 2 times expenses. Right, 2x. I assume it's able to understand that the fact that 2x means 2 times, which I thought was pretty neat. But here we can see all the points where revenue had exceeded 2 times more expenses. So, pretty good profit margins for any of those months there. This one's a little bit more complicated. So we say, show me when we had a profit margin that was greater than 60%. A little bit more of a complicated query, but you could still see that GPT is able to write a flawless SQL command to be able to execute put this into an SQL executor to get the right amount of data back. And we can see we've been returned the rows where exactly we had 60% margin. I could change that to 90%. And again, it would be, another flawless SQL command. We could see 2 months where we had a profit margin greater than 90%. Those are some juicy months. A lot of revenue, not many expenses. Now we could even add to that. So we could even say, but even when expenses were, so 50%, but when expenses were lower than 2,000. So adding some more complexity to the SQL query, but yet again, it's still able to understand all these nuances here and generate the perfect SQL query that gets executed and returns the perfect results for us. It is really, really good. With a bit of prompt engineering, the SQL queries that get generated are flawless. And they can work. I mean, in this situation, we're only working with one SQL table. We could work with multiple SQL tables and multiple schemas. It doesn't matter. It's just you'll be able to see that it's able to, based on a schema, is able to understand all of the relevant nuances here. Now, by the way, the entire source code behind this application will be freely available. So I do have a GitHub link where you can view the entire source code. But what I'll do is I will go through first the entire source code so you understand exactly how this works. Okay, great. So the first thing we're going to do here is in the source code repository, I have a script called Azure OpenAI.py. And this is where you could set up your utility function to get completion from GPT-4, GPT-3. By the way, one thing I think is really important here, which if you can, it's always recommended to use GPT-4 when you need to be able to output structured data. That is really important. I've seen post my last webinar on this. I've seen people try to use GPT 3.5, but there has been some funny outputs with 3.5 for this type of application. But all I'm doing here in the source code is defining a function, which is get completion from messages. It is just simply a utility function to make OpenAI calls. Very simple, nothing, nothing complicated here. And again, this will all be freely available in the GitHub, so you don't need to write this out yourself. And then what I do is in SQLDB.py, I'm essentially just initializing a database and defining some utility functions and also creating some fake data. So in this example, you don't have to use this script, but in this example, I'm just creating a finance table, which we query, and then I'm inserting some fake data into it. And then I've also defined a function here to get the schema representation, which will be very important, in the future. The schema representation is effectively this. What this function does is just generates the entire schema of a SQL table, which is very important, especially when it comes to the prompt engineering side of this. So I have another script called prompts.py, and you can see here I have this is how I've defined the system message that would be executed within GPT-4. So it's typical you're an AI assistant that is able to convert natural language into a properly formatted SQL query. I've said that then the table you will be querying is called finances, and here's the schema. So whenever you're kind of trying to steer GPT in a different direction, it's always very useful to give as much context as possible before you actually tell it how you want to structure the output. Now, in this application, I need GPT to only give me the SQL query so I can pass that SQL query into an executor. That's the key here. So what I've done at the end is to say that you must always output your answer in JSON format with the following key value pairs. I found that this structure works extremely well when you want GPT to give you a structured output, especially in JSON form. So I always always recommend in that previous example, always recommend for anyone to specifically detail their key value pairs when they want when they want GPT to output a structured JSON form. So here's the main application. This is the main application, which renders the entire, which renders that basic application I showed you. But here we have a simple function at the top, which actually runs the SQL query. This is effectively our SQL executor. It takes a query in, a connection object, and actually runs the query itself. So it will become very useful a little bit later. But here we create a connection object. We get the schema representation. Here is just the title of the web application. Here is where I define if you haven't used Streamlit before, by the way, I should mention it is a really easy Python library that you can use to build pretty much any web application in the shortest possible time. It is really, really useful. So the input field, I've put in I've just defined a simple text input here where I put a message in. Now, once the user has placed a message, just like I showed you in that previous application, the key here is to format that message. So what I'm doing here is I'm getting this schema from the finance table, right? And I'm formatting it into the schema placeholder, which we defined in the system message. So right now, at this point, from line 29 onwards, the GPT system prompt is properly formatted with the schema from the finances table. Then what I'm doing in line 32 is getting the actual full completion from GPT with the system message and the user message. The user message, like I showed you in the previous example, could be, show me all the months where we had negative, where we incurred a loss. That's a perfectly fine user message. Now, remember, we expect the response from GPT to be in JSON format with two key value pairs, the first being query and error. So what we do in line 33 is we actually load that output into a JSON object. And then in line 34, we're getting the actual query by keying the query value from the JSON response. So at this point, we have actually created an entire variable in line 34, which holds the full SQL command. And that's really key here, because then what we're doing from that point onwards is we're showing in the application the actual generated SQL query. But most importantly, we're taking that query, and in line 42, we're calling the utility function we defined earlier to query the database with that query, and then show the results, which you can see there. So, and if an error has occurred, then we show an error. But that is essentially the entire main building blocks to building an application that you can query, that you can actually execute SQL query commands over without knowing any SQL. This is the whole point. It bridges the gap between people who know zero SQL that actually need to be able to retrieve information from these databases or these enterprise databases. They can just do so now in natural language. It really closes the gap between being non-technically proficient to being very technically proficient. And that is really the main building block to the application. Again, this entire source code will be available on GitHub. But the main, so my entire goal for this is, you may be in an organization, if you're listening, you may be in an organization where you are writing applications that serve, let's say, or writing internal applications that serve as tools that internal stakeholders can use to get information about things, about certain things in a company. But now you could introduce a far better user experience by allowing anyone to just convert natural language into SQL and get those results. So anyone doesn't really know. I mean, any stakeholder that needs to get information from internal databases, they don't really need to know code anymore. They don't need to know SQL anymore. They just need to know how to write a nice English sentence about what they want. And this is really key. It's key for executives of company that need to know information like, especially like profits and expenses over time, that may be stored in SQL DB somewhere. It's key for internal stakeholders that use internal dashboards that query SQL databases all the time to serve information. You can now level up their stakeholders' experience by providing a natural language interface. And really, I think that's probably the key trend we're seeing here is that more and more a important programming language now which is being developed is English, and that really comes down to writing a really good prompt and writing really good queries that are able to generate meaningful outputs. And so we are shifting into a paradigm where English is becoming a key programming language, which sounds a bit strange, but also appropriate in this new paradigm. But anyway, I wanted to keep this this webinar short and sweet. I didn't really want to go beyond 20 minutes because I found that 20 minutes is the sweet spot for these technical webinars. Yeah, if you enjoyed listening to this, please connect with me on LinkedIn.